It's me, Tony. The subtitle, Value-Oriented Programming in an Object-Oriented World, was picked very specifically because my friend Wampe, he did a talk here last year called Most Valuable Values. He's doing a talk next month called Value-Oriented Design in an Object-Oriented System. Value-Oriented Programming in an Object-Oriented World. We've been discussing things, right? Also, he did a talk called Postmodern Immutable Data Structures. I did a talk called Postmodern C++. You know, I'm starting to think maybe we're the same person. Also, this was in my talk. People probably remember this slide. Kevlin Henney may also be me. I'm getting a little worried. I don't sleep much. You know, what's that movie? Fight Club. Thank you. But go. This, you know, for now I'm just Wampe. It's just me and Wampe this time. So this is my talk. I don't usually like to give an outline, but I think this one needs an outline. So here's my outline. And what I mean is I'm going to kind of start general, and we'll kind of work our way towards the specifics. And just to lower expectations, we'll kind of end on May, right? Meh. And it's more the journey than the destination. Okay. So first thing I want to talk about is good code, because that's probably why we're all here. And to talk about good code, I need some help from Hannah. She helped me with JavaScript. Oh, do we want audio now? All right. War Games, Matthew Broderick, 1983. All right, good code. What's good code? I can't see you, so don't raise your hand. I also do lock-free programming, so everyone just talk at once. Give me words for good code. Maintainable, of course. Simple. Correct. What was that one? Testable. Probably someone said readable. Come on, keep going. Code you read this morning? No, don't have that one. How about this one? How about this one? How fast? Efficient? Unsurprising? Unsurprising? Intuitive? What? Oh, I don't know if I got that one. Let's see what else I got here. How about these ones? I mean, I have these because I asked the internet, right? That's how you do these things. Yeah, you know, people are like, good code isn't, because it just doesn't exist. But these are the types of things we always hear, right? And in particular, I started wondering, okay, why is it? What's so important about maintainable and readable and understandable code? That's only important if you intend to change the code or change the code around this code. You tend to call this code and things like that. If you were to write code and never touch it again, you don't care if it's maintainable and good code, right? Kate said that she's done prototyping in Smalltalk, and then she throws the prototype away, right? It's like, it's still good code because Kate wrote it, but it doesn't have to be good code. So I want to, to me, it's essential to know what is the real test of good code. And to me, the test of good code is good code begets good code. Good code encourages good code causes good code, which is a terrible definition because it's recursive. It's the exact same definition of bad code. Bad code begets bad code. So that's why we have the other half of the definition is good code works, right? That's it. This is kind of subtle and kind of just a silly thing, but to me, it's very fundamental. And because all of those things that we think of, these things make up good code, they don't always agree with each other. And sometimes you have to decide, you know, which way am I going to go? And then my criteria is which one of these directions will lead to future code continuing to be good, right? And basically all code kind of deteriorates. And the code that deteriorates more slowly, you can go back to the beginning and say that was good code because it lasted as it continued to beget more good code as we went along, okay? So that's what I'm going to use as my definition of good code. Let's see if I can. There we go. Good code. So value types. It's kind of one of the things on the talk. And actually, it's both value types and object types. Value types, you've probably seen some talks about it already. Int. Int is the classic value type string. Value types tend to be just simple types that are copyable, maybe move only, but copyable. And when I mean copyable, I mean copy or copy not. There is no shallow. So if you have something like a vector or a string, and it's pointing to that's kind of how vector works. When you copy it, you don't get this, you get this, right? Copies are disjoint. That's essential property of value types. Or if you don't, Master Yoda or Master Stepanov calls it regular. You make copies, copies are equal, but copies are disjoint. You change one, the other one doesn't change. Okay? And then that helps you build things that are more mathematical. And I've got this weird kind of thing called values are immutable yet ephemeral. And what I mean by that is the number 17 is always the value 17. It never changes. It might show up in an int, and that int can come and go, but the value, which is the important part, it never changes, and it just moves through your program. And it was in this int for a while, and it got passed over to this int, and then it got returned, and the int itself wasn't important, the value was important. And that helps you make more mathematical code. And as an example, I have the function in my code base called generate point cloud, which you can probably guess it generates a point cloud, but what do I mean by that? This is what my code does. You shine projectors on objects, you press a button, it does a bunch of patterns, and then it figures out where the object is and it can color it correctly, right? And there's a step in here where based on the patterns of light, I do triangulation and stuff like that, and you get a point cloud. That's like a 3D point cloud. So, generate point cloud. Anyone want to guess what it returns? Yeah, how about a point cloud? Vector of points is actually more correct, but it should be a point cloud. What's it take in? Images, right? Okay, simple function, takes some images, gives you a point cloud. Maybe there's some more data there, but basically that's what it does, right? And you look at this function, you go, I understand that function. I don't understand the internals of that function. It might do magic things, but I can call that function. I kind of know what to expect. I can test this function, right? It's a nice function. Our function looks like this. This is what our function really is. It's on model, it takes no parameters and returns nothing. It's like, wait, what's that do? I don't know what this function does anymore. I kind of know it generates point cloud, but I don't know what its inputs are. Which parts of model is it using? I don't like this function. This is not the way. I'd rather write, which of these can you test more easily? One of them I have to build a whole model before I can even test this function, right? So these functions, which Stepanov calls regular functions, where if you pass in the same inputs, you get the same outputs, and there's no side effects, things like that. Regular functions are, you can reason about them more easily, you can test them more easily, right? So that's value types. Objects, also very useful. Button tends to be an object. Go look at some object-oriented programming languages. Everything's an object. They tend to be non-copyable, right? You don't want to pass in a button into a function and suddenly you have two buttons in your UI because you passed by value, right? Button tends to be an object and it's non-copyable, but they can change. The button can be clicked or not clicked, and you can observe that change over time. And like Sean did a whole talk on relationships, you can have relationships between objects, and they can be long-lasting relationships. And I use objects in our code base. We have projectors because it's connected to a real projector. When I call projector.shutter, the real projector shutters, right? If I can't copy a projector and get two physical projectors, that would be awesome, but it would also be really slow because every function call would take a week to manufacture another projector, right? Same with cameras and all our UI, it's all object-oriented. And it's also object-oriented because we work with various projectors, various types of cameras, so we use polymorphism to abstract away those details, right? So these are the two things. You guys kind of know what these are, right? But just want to make sure I got it covered. And over here, you have pointers, right? We can wrap them up in unique pointers and shared pointers, but it's like you have to deal with pointers. It's like, oh, no pointers. And over here, it's, oh, no pointers. So that's kind of nice. And here's my other, and when I say my, I mean Wampe, his talk, and this was like totally independently made, but it's the exact same stuff, right? The reason I wanted to show it is because he has a really nice ramp shade, because you can have things that are kind of in between, right? And also, if you take an int, which feels like a value, and you make it a global variable, suddenly it's an object, because everyone can reference it, and it has this lifetime, and you can, it's that int, not just any int, right? So, you can have types that kind of fade in between, but when you design a type, you should probably know, I want this to act like a value, or I want this to act like an object. All right. Some philosophers don't like objects. Postulated universe composed of objects, truth is eliminated. I don't even know what it means, but it's from Ben. So that's value types. I need to talk about MVC, model view controller. Model view controller was invented at Xerox PARC in 1978, the place where everything was invented, by Trygve Ringskau. He was just a student at the time, and everyone's been using it since. And just to quickly explain, everyone knows what model view controller is, but model keeps the data. It also is the thing that maintains the invariance of the data. Like Sean talks about, the data should be in a valid state. That's model's job. You don't just set X to 100. You ask model to set X to 100, and model might say, no, I can't do that, right? It maintains the interrelationships between the parts of the model. The thing everyone forgets, in the original plan, it's the user's mental model. And the user's mental model of the problem that your computer is solving should match your data model. And it should be obvious to the user what the mental model of your program is, and it matches what they're thinking. And everyone always forgets that. So we don't actually know what model means in model view controller because we leave that out. View is basically what you think it is. Views might not show the whole view. You might have multiple views on the same data, fairly normal. Controller, who knows what controller is? No one. The answer is no one. No one knows what controller is. Including the next person who used it after Trygve left Park. Jim Alcoff uses the term controller somewhat differently than me. It's been unknown from day one exactly what controller is. That's why no one knows what it is. But originally, the idea was it handles the user input. It translates input into a command to the model, asking model, could you do this for me, please? And the proper way to think of model view controller is this. You've got your console. It has your data in it. You view it on your TV. And controller is like a controller. It is a thing that takes the input and decides to, you go left on the stick and you move the character left. Model decides whether the character can move left or not, right? So it should have actually been called controller model view because that's the flow, right? You do the thing. Model might say, I'm sorry, Dave, I can't do that, Dave. And then, the view will update. And then, of course, don't forget the user. So it's actually user controller model view. And the user gets the input at the end from the view. And it's actually user model, user controller model view. Because the user has this intent, and what they think the model is, they do an action with their fingers through the controller to the model, and then they see the result. And then they're like, what? Because if your model didn't match their mental model. And you should look at his future work on, because he was a young guy when he did model view controller, and he's done a lot of work after that on the user's mental model. And he quotes it's a great book, The Design of Everyday Things. I mean, this is the slide I could find in black and white. It's all I could find. But he uses the design of everyday things as another example of, the everyday things we use, we want to be designed to our model, and computers should be the same way. It should be designed for what the user has in their head. But to build this model view controller thing, ever since, this, it was originally done in Smalltalk, and it uses the observer patterns, basically where the observer pattern came from. And nowadays we can use signals and slots in different ways, but the observer pattern, I assume most people know, but it's just so you can hook up to model and say, hey, if something changes, call me back. Here's a function I want you to call when X changes. Just tell me and I will update X in the view. That's the observer pattern, right? You can observe when something changes. Sometimes it's called publish, subscribe. You subscribe to changes, all these different names. And one of the good things about the observer pattern is you can have multiple views, right? You could have 3 different views showing different angles of the same thing, and they all connect to the same observer, and it tells everyone that it's changed, right? We can also use the observer pattern on the controller side, and that often happens, but it's not as important because you don't want 5 different things listening to the controller. The controller should just be, oh, move left, tell model, don't tell anyone else. Everyone else should wait till after model has decided what to do about it, right? And if you do decide to write your own observer pattern, go watch this talk. This was a couple years ago. You will do it wrong, guaranteed. Because at the end, you know, the punchline of that talk is there's only 2 choices and they're both wrong. So this is model view controller. Of course, what happened was we put the view and the controller together. This is why I picked Nintendo, and because my kids love Nintendo. And in all our graphical user interfaces, view and controller have been merged together, and even in the original, view and controller were very closely tied together. And it's also the reason why no one knows what controller is. People are like, is it just the glue code between these things? It's like, just forget controller exists. It's basically model. Trygve later called it model tool. There's just the 2 things, right? So that's model view controller. So what's the problem, right? We've got this model view controller. Everything sounds good. This is the problem. So we all know what he says, right? If you get the extended DVD version, you get the full thing. States leads to objects, objects leads to references, references leads to sharing, sharing leads to entanglement, and entanglement leads to suffering. Yoda knows this, we all know this, right? To me, it is the #1 problem in programming. I don't care about whether you use OOP or functional or whatever else. I don't care where you put your brackets. I don't care which language. The #1 problem is code is not kept separate. Things are entangled. Don't do that, and name things well. Keep your code isolated. So that's the problem. Very simple, big letters. Problem is entanglement. And sticking with MVC, there's all these other symptoms you'll see if you do MVC code. These are symptoms of the problem. And it doesn't matter exactly what these are. You've probably seen most of them. But it's kind of weird because this does seem separated, right? You've got view is separated from model, is separated from controller. Maybe controller and view have kind of got tied, but model is fairly well separated. And so where's the entanglement? And also, the entanglement's necessary. If you want the view to show the model, they need to be connected, right? So we can't avoid entanglement. Just like from Yoda, it's like state leads to suffering. It's like, well, state is what we do with computers. So how do I avoid it, right? But so let's look at what's maybe causing some of these problems. Here's model, and in my code base, our model class is literally all caps model, because it's a giant class and everything is in it, and you've got to yell it when you say it. It's like model. It's like, oh no, I have to update model again, right? And this is kind of roughly, somewhat redacted. This is actually better than our architecture. This is what I want is the direction I'm trying to get to in our architecture. So let's say we just want to take one little piece of model and display it, make a view of this, right? So it's channel. What's channel? No one knows what channel is. Here's a 2D example of what we do. You've got 4 projectors. They're projecting these images onto the screen. And you can see at the beginning over there, they're not, like the top left projector is not showing all the pixels. It's just got a portion of the pixels. And those portions of the pixels are supposed to line up with the other projectors. And if you put the projectors in exactly the right spot, it'll all line up and look beautiful, right? But that's the user's mental model. It's the theory. Reality is that, right? Theory is this. We want it to look like that. So, there's those same pixels from that projector, but put into the right spot. And this, you pre-say, because if this is a video playing, the videos might have been rendered 2 years ago. And when they carve the video up, because you could have like 20 projectors or 50 projectors, right? So you don't pass all the video to each projector, you just pass its chunk, right? And this has all been pre-rendered. And so the person who pre-rendered it's not gonna render it over again. They're gonna say, look, this top left projector is getting pixels from 0 to 65%, and that will overlap with the other projector, and we'll blend them. And what my product does is like turn theory into reality, right? That was reality. We now match it with what you were hoping for. But anyhow, that's what a channel is. It's just 4 numbers, right? So the UI for a channel is simple thing. How we make it work is hard, but the UI is very simple. So that's what we just, as an example, we want to build that UI, okay? So there's the data, there's the thing. Here's what it looks like behind the code. Channel is 4 numbers. Maybe it's private, maybe it's not, whatever. It's just a struct of 4 numbers. Layout has a vector of channels in it, right? Nice simple code. Layout is the other thing that above, the next box up. And we have these things. We want to connect them to the data, right? So how do we do that? If we're using something like Qt or other signal slot mechanisms, the left widget is going to need a function called setLeft or something to, when the UI changes, we'll call setLeft. And also it needs the back channel of if something else changes the left number, the UI has to update. So the left signal, or that'll be like left changed signal. But I want left signal, right signal, like I'm driving a car. The left signal is the thing I'll connect to know that the data is updated, right? And I need one of these for each of my 4 values. So where am I going to find these functions, right? Well, the obvious answer is channel. We just turn channel into a Q object. Q object gives you all this powerful stuff with signals and slots. And now I can connect my data to, or my UI to the data. Channel now, a minute ago, channel was a value. It's just like a struct, it just acts like a value. Now channel is an object. And we're building a relationship with it, and it's gonna stick around, and we're gonna make connections to it. Also now channel has become a pointer, right? So I now have a vector of pointers to channels, not vector of channels. It's kind of important. And so we had this nice, really nice function that I want to exist. Similarly, I have this other very important function. It's the function that solves the user's problem, right? It figures out where the projectors have to go. It takes the layout, which is all the channels where you want them to land. It takes the info that we gathered with our cameras of where the projectors currently are, and it gives you back a solution, right? That's an understandable function. And by the way, that function is threaded. You let that happen while the UI stays live. So if you go to any of my lock-free talks, step 1 in threaded coding is don't share data. Just like in kindergarten, you learn how to share. Don't do that. So I'm going to make a copy of the layout and maybe a copy of the gathered data. The gathered data is probably immutable at this stage, so maybe they don't need to copy it, but I'm going to make a copy of layout, right? And so it's like, oh, layout used to be default copyable. It was just a vector of numbers. Now I have to write a construct, it's not hard. I can do it. I can make layout copyable. But then you ask those same questions that Sean asked. It's like, oh, I copy these channels. I don't copy the pointers. I have to make new channels. They're not connected anymore. And is that what you really want and stuff? And I can make a solution for this, right? As programmers, we can always find a solution. It's just not, the obvious solution is no longer maybe the right solution, right? You're just gonna be like, oh, I can solve it, but good code begets good code by just, the obvious solution is the best solution. Right? That's the goal. So again, of course, my solve function is actually this currently, but I want it to be that. That's my goal. And so I kind of don't like where this is headed, right? Because this is going down going down a path I cannot follow. On second thought, let's not go there. 'Tis but a silly place. So I really prefer, because before my data in the back end was just just data, and I just had functions that worked. And if I ever want to, distribute this, put the UI here, put the data over there, put it in multiple machines and all this stuff, I'd really like the data to just be data. So I don't think I want to mess with channel. But looking at channel, I think, oh, there's something I can do here. Channel can help me. How about we stop having these four connections, and what I really want is the UI has one function, right? It calls set channel, and when the channel changes, it wants to be updated. And now if you change just left, well, we'll send all four numbers to the back end. We'll call set channel. It's like, this is not a problem. This is 4 doubles, floats, or whatever, instead of 1, and it's UI time. You're not trying to be efficient here. I want to be efficient in the back end. I don't need to be efficient. And then also, if I could someday later, change my UI to be like a box that I can drag around and stuff, then this doesn't change. It's still set channel. And in general, I think you should communicate using larger values. That's a useful thing to do. And you're raising your level of abstraction one level. And like even layout, like layout's a big object. It's got hundreds of, if you had hundreds of projectors, that's a big project. It's like, oh, it's still 1,000 floats. Like, I don't care if I copied layout. It's not an image. It's not millions, right? Layout's maybe a little big for this problem, but so to me, this is a win, right? We've got a smaller problem. We've only got one connection we have to worry about. So then the obvious thing is, if I'm not going to connect to channel, who am I connect to, right? And easy thing to do is you just start going up the tree. It's like, well, maybe layout, can layout become a Q object or something like that, or maybe whatever his parent is. The parent of layout is actually called theory, because it's like theory versus reality, and that's what it does. It turns theory into reality. Or maybe model. And if you just look up the call chain, what you find is that model is already a Q object in our code base. So it's like, hey, that's not bad. Maybe I'll just start there, right? And it's kind of good because model will then, if all the changes go through model, model's got control of everything. It can make sure all the interrelationships stay intact. And it's actually better than what our code does now. I don't even want to describe what our code does now. And if you look at something like React, that's how React works. React has a store that you do store dot whatever it is, do action, whatever. You hand it actions and the things happen, and then it comes back around, the UI updates. And it's actually a very value-oriented system where you get a whole new doc on every change, but it's like efficient underneath and stuff like that. So it's not a bad way of doing things. But we do have something of a problem in that now model has hundreds of functions on it. And imagine if you didn't have set channel, but you had set channel left, set channel right. Like if every single number in the string in your UI had to all go through model. Model's a giant kitchen sink of things, which is exactly what it is in our code base right now. And unlimited power, right? I have to understand why my next slide is my next slide. Yeah, okay. I don't mean that model has unlimited power, because it does. Like that's just inherently, it has everything. It's going to have unlimited power. But when you get everyone connecting to model, that means you're handing model around to everyone. And so now everyone has unlimited power, right? So remember, good code begets good code works. When you start handing model to everyone, it's, unlimited power, you get things like this, right? I've got model, I've got a problem I need to solve right now. So I call model, get foo, get power, this is the thing I need, right? Because you passed me model, but I really wanted this other thing. And I think our record is like 5 levels or something like that in our code base. I don't know. And this is bad because it goes against this law that someone made. It's called law of Demeter. And this law says don't do that. That's basically what the law says. Yeah. What it really says is that this function at the end, get the thing I need right now, that function should, if you need that, maybe that function should be on model, right? And it's like, ask model will delegate as needed, but just ask model. Or alternatively, why why didn't your function that's calling this, why didn't it get bar? Why did you give it model? You should have given it a smaller interface. Or why didn't you just hand it thing if that's what it needed, right? Why did you give it the kitchen sink? There's a C++ cone out there about this that I should have had slides for, but show that later maybe. So this is also something I kind of want to avoid this giving everyone unlimited power in my code base. So sorry. If I back up and think about, okay, I went this way, I didn't like it. I went this other way, I didn't like it. I mean, you guys are thinking, well, he's only got 2 choices left, but I want to turn around and stop and think for a second. It's like the API that I'm trying to build here is defined by the code that calls it, not by the code that implements it. Right? The code that calls it is this code down here, is UI. The UI is the one looking for the right API, right? So, and the full API is just 3 functions: get the channel, set the channel, and like somehow watch the channel. Like I want to pass a lambda in, say, call me when the channel changes. Right? Sounds like television, watch the channel. So let's put this in an API, right? And hope you notice this is not valid C++. Like the first one is a function declaration. The second one's missing the void. The third one's a function call, right? But whatever, you get the idea of what I'm trying to say. I want an API that looks like this. And if you stop for a few minutes and think about this API, you're like, actually, almost all my UI wants an API that looks like this, right? So it's like, look, why don't we just build this? And what happens when we build this? And this is from Wampe. One, it's generic. We get to reuse it a lot. It's reifying the entanglement. Sean Parent talked about witnessing relationships. Witnessing relationship is the wedding ring represents the relationship, but it isn't the relationship. This case, the in-out object is the relationship. You pass it into the channel, and that's how it's going to communicate. When you destroy the in-out, the relationship's gone. So that's why you use reification instead of witness, if anyone cares about these precise words. Sean and I do. We talked about this. And what I feel is important is the UI, which was this object and thing and all this stuff going on in the UI. The UI is now just a function call. Pretty much the UI's whole point of existence is to call set. That's what it does. It is now a simple function, right? Like this is a simple function. The UI is just a simple function. It calls set. And the call graph is now simpler because in signals and slots, they give you lots of power. One of the things it allows you to do is have 3 people listening to the UI. So if you want to go like, oh, I changed right to 65, what happened? And you're like, oh, I found a connection. It goes and it does this. But it's like, no, there's actually 3 connections. It goes here, it goes there, and it goes this other direction. And you might not even see that in the code because it's hidden. But now, when the UI changes, one function gets called, and you can trace into that function. And maybe that function does 3 things, but it's here in this simple function. It's not hidden, right? And now you have limited power, which is actually better than unlimited power. Because you're not going to do the things you shouldn't be doing. It's leading you in the right direction, right? This is how good code begets good code. And now I can use Qt in my UI and not use Qt in my backend if I care to, or I can switch systems from one from the other. And to me, this is more testable. If I want to, my set and stuff, I can test this on its own. And my UI, I could create just this UI with a different in-out that wasn't connected to the model, it was just connected to some test harness, and I could test my UI. And in terms of solid, if you've all heard of solid, there's all of solid. I promise, next year my talk is about solid. There's good and bad about solid that I can't talk about now, but single responsibility sounds like a good thing, and the in-out class has one responsibility to maintain the relationship. And interface segregation is that whole idea of just pass the small interface, don't pass a giant interface because people will misuse it. So just pass the interface that's needed. This is the only interface the UI needs, so that's what you pass. Don't pass model. So maybe those are good. People seem to like that, so we've captured 2 of them. what's bad about in-out? I don't know if either of these are bad. I don't think they're bad at all, but they're worth mentioning. In-out is probably a kind of like a future promise. There's probably another side to it, right? In-out is the side that the UI gets, but there's got to be someone on the other side implementing, making sure the calls happen, and it's a conduit between the two pieces. So the other side has to exist. Future promise has some overhead, like a shared state and everything. There's an allocation. I think you can. Well, I did a talk 5 years ago or something on how to get rid of the allocation in future promise. It's online. And maybe you can't do it for standard future promise because there's some constraints. I think you might be able to. But I could definitely do it here because I've got more control over it. And in-out is probably move-only type because you only want one connection. And that makes that problem easier. And there's obviously a hidden reference inside the in-out class because it's connected to the data somewhere. So there's a chance of a dangling reference. But like future promise handles that by one side can go away or the other side can go away, and it might throw an exception or something, but it won't lead to undefined behavior because each side knows when the other goes away. So we can do the same thing here. But of all these things, to me, the important one is that it becomes the relationship. Sean started his talk with saying, we never think about the relationships in the code. And now I've turned the relationship into an object in the code that you can be like, right there's the relationship. And if anything's going wrong, you can be like, it's happening here. And you don't have 5 different ways of doing it for 5 different pieces of UI. It's all happening in the same spot. I'm going fast, as usual. So there's my in-out thing, and I construct it somehow, and I hand it to the UI, and we're good. And I still have this question though: is where did it come from, right? What are the parameters to the constructor? Where did this thing come from? Well, there's a good chance what we do is, maybe layout is the place to hook this up. So maybe we turn layout in. We can either wrap it with a layout for UI, or layout for UI could be this like parallel object, which is not always the best thing, but or maybe layout for UI is just the interface that the UI gets for where you get your channels from, right? Maybe instead of tacking it onto layout, we could tack it onto layout parent, or we could tack it onto model if that's the way it works out. And which one you do is it might come from. Let's imagine that changing channel also affects that XYZYPR thing over there, right? Whatever that is. If there's a relationship between those things, then when you change the channel, you should probably not change it through channel. You shouldn't change it through layout. You should change it through their common owner. And you tell that guy, hey, change the channel, and that guy will go, oh, when I change channel, I know to do this, and I know also to do that, right? We could just drill a hole between these two things, and like add an in-out or put signals between them, but at least the in-out you would see. Signals totally get lost in your code base. You don't know they exist. You can find them. You can search for connect, but it's hard to find. But I don't think you want to drill directly across. You want to go up to the guy who's in charge of that thing. And by using an interface, maybe this interface starts out by living on top of layout, and everything's working well. And the day that you realize that, oh no, there's a relationship between here and there, then you move this interface up one. You ask the layout parent to get the in-out stuff for you. But none of this code down here changes because it's all the same. So, meh. I don't care. I don't care where this lives now. It lives, the UI doesn't care, and I can change whenever I want where this lives. And I swear this thing took me over an hour every time I was looking through this, and I said I was going to end on meh. That's the end. I skipped all the side branches that I thought I wouldn't resist skipping. Right? That's why I went fast. Questions? Just silence. Oh.
Hi. So one of the big things you said was to make the model you use reflect the user's mental model of the application. One thing that I find is that lots of times in my applications, the main purpose of the application is because the model, the things that the user wants to interact with don't have a clean model. Do you have any advice for how to deal with that?
It's hard. Let me back up. Let me back up so far that I have to do it this way. If only I had a cursor. Sorry, I guess I got lots of time, but. We got our mental model wrong in our code base. To us, the mental model is you got projectors, you want to align projectors, and our whole code base is all about projectors because we're a projector company, we make projectors, we sell software for projectors, this is what we do. The user's mental model is a canvas on the wall, right? They don't actually even care about the projector stuff. They just want this picture on the wall. So part of what I'm doing is changing the mental model so that it matches. And you think, well, what's the big deal? What's the difference? One of the differences is that it turns out you can have multiple projectors for one channel. They're not a one-to-one. Because what happens is, if this isn't bright enough, you just double the number of projectors. You're just like, each corner gets 4 projectors, and then it's 4 times as bright. So you get 4 projectors in one channel. And yeah, you get it wrong. That's my whole job at work right now is to build the correct model because we didn't understand what the problem was, right? That's not advice, it's more of an example. I mean, sometimes it takes time, right? Your first try at something doesn't work, you try again. And it is something you kind of get used to over time because you start looking for, often a user will say, geez, I wish I wish I had a hotkey for save as and then rename the file, right? I just want to save like file 1 and then I want to save file 2 and I want to save file 3. I want to save off these things. So could you give me a quick save as thing? And you're like, did you want version control? Is that what you wanted? And they're like, what's version control, right? So the user doesn't also always know what they want and and then you're like, here, let me show you something. Then you end up agreeing, this is what's going on here. But most of the problems we solve, sometimes we're solving kind of new problems, but also we're often solving old problems in a new way or doing it faster. Like this stuff, people would do it on the projector, and there's all these dials and controls on the projector, and you can do it by hand, and you can make it work. And it's like, that's why people like our software. It's like, no, press a button, and it's done. So often you're solving existing problems, so you can look to that to say, well, what's the current mental model? Which is why we got ours wrong, because the current mental model was work on this projector and twiddle some numbers. I don't know if I answered anything there, but.
Oh, that's very helpful, thank you.
Yeah. I don't think it increases entanglement. Well, obviously if you make the object too large and it's like every piece of UI just connect, copies model everywhere, right? But it decreases entanglement because you have less connections, right? Instead of having 4 connections to channel, you've got 1 connection to channel, right? And it's basically do it at the right level, which is always, good advice is like, well, just do it right. But channel feels like the right level because it's the fact that channel is left, right, top, bottom is like detail. You don't even care. It's like channel. Channel is this we found a good model, right? And we called it channel. And the users also were already calling it channels. Before we ever came out here, they already carved up videos into channels, right? It's like, oh, we all know what a channel is. And so it feels like the right size to be connecting. But you don't want to connect, you want it connected to what's in your UI. If my UI is just channel, I'm not going to connect to layout because layout's got a lot more things in it. I'm going to connect to the smallest object that has all my pieces in it, right? So for the channel UI, the smallest object is a channel. Right? Yeah, I mean, if your object, you made this object because it was a good abstraction, right? So keep the abstraction. Keep that abstraction in your UI, keep it in your code base, pass it around. I just spent, just last week, you know, when you go away for a week at work, what you want to do is check in a 100-file change, right? That's what I did on Friday before I left. Because I rewrote our image class, right? It's a fundamental class we have, which, like vector, image class is small, right? It's got like a pointer and in width, height, and format. That's all it is. But it's got a pointer to a big block of data. That's the pixels. But the image class itself is 32 bytes or something. We allocate images everywhere. Right? We allocate the small block, which allocates the big block. And we did that because there was no move semantics, right? So images were always pointers, and you pass them around. And we started using shared pointers and unique pointers. I'm like, that's better. But I'm like, no. The right answer is that image should act like a value. I just don't want to copy it accidentally because it's huge, right? So instead, image becomes a move-only type. And you just pass it around. And either you're doing a function that's going to like look at the pixels and come up with some numbers, and then you pass in a const ref to an image. Or you're a function that's going to take the image and process it, move it along, and you're probably just going to move it through. Like the function that the camera returns an image, move only, and then hands it to the next piece, and then, they go down the pipeline. Because image is the right abstraction. So I turned it into, even though you think, oh, an image is an object because it's huge, I've turned it into a value. So you just pass it around, right? And I think you just find they're hiding in your code base. All these values waiting to come out. And usually you find them kind of in the back end of your code base, but it depends what you wrote first. If you wrote a lot of UI stuff first, you start building objects. Like Matt had a really good talk on 3 ways of writing a ray tracer, right? And you could make your circle object, or you can make your circle, and okay, Matt was wrong about one thing. Circles or spheres don't have a position. This is a whole nother talk. Spheres only have a radius. 2 spheres are the same if they have the same radius. They're in different positions, but position is an extrinsic property of the sphere, not an intrinsic property of the sphere. So a sphere, the position of a sphere, go back to Sean's talk, is a relationship between the sphere and the world that it's in, right? So it's actually good to separate those 2 things. I mean, at the end of the day, you need them together because you're doing intersection. We work with domes. We do the exact same intersection code of like intersect this ray with this dome, right? We have to take the second solution instead of the first solution like Matt does because we do the inside of the dome. But you tend to find, you just look through your code and try to decide why is this an object? That first question, should this be an object or should this be a value? And it's kind of just practice over time. Write some code where you try it one way and try it another way, and you'd be like, no, this feels more like a value. And basically, I start with value. That's my rule. Unless I know it's a button or a projector or something, I know it has to be an object because I can't copy it. I had slides in here from before. The Queen of Clubs, right? The Queen of Clubs has a rank, right? Like a card class has a rank, like queen, and a suit, like clubs, right? So the Queen of Clubs, is that a value or is that an object? So I was writing a card game because my kids are like, why don't you ever write like a game or something? So I started out and I'm like, okay, card class. This is simple. It's got 2 variables in it. Blah, blah, blah. Like copy constructor. I'm like, do I want to copy the Queen of Clubs? Because then I'll have 2 of them in my, you shouldn't have 2 queens of clubs in a single deck, right? I'm like, oh, so I shouldn't make it, I shouldn't copy it. It should be an object because it's the Queen of Clubs. It's the, right? And it might be in your hand, and then it's in the deck, and then it's played on the table. It has relationships with the rest of the world, But then on the other hand, like, if I'm doing kind of prediction. I'm doing like an AI or something. I like, well, I want to try this. I want to try, what if I had the queen of clubs? Like I want to do this whole tree of try stuff. And then it's like, well, now I do want to copy the queen of clubs. I want a copy of the whole document so I can try stuff. And then, so I didn't finish the game. Actually, someone spilled water on my laptop. So make backups. It was a really nice laptop too. But practice and lean towards values is my opinion. Unless you know, even if that's one of the things I forgot to say. That's why I'm going so fast. You can go in between. Like if you want polymorphism, you tend to go towards object. But if you know that's like an open set of things, like we load our projector and camera drivers so that I don't even know what they are until we're running. We like the dynamic libraries, right? But I mentioned the channel. We actually have different types of channels. So I have 5 different types of channels. I could make that polymorphic object, but instead I could make that a variant so that I keep channel as a value type, because I really don't want it to be because in my code it is an object right now, and I've seen the mess that it causes, right? Objects are great for certain things, but values are really great for a lot of things, and I find every time I've leaned towards value, I've been happy about it. So I'm sure they were somehow connected to the original question. This is.
Hey Tony, thanks for another great talk. I have a question about your definition of good code and whether that's actually how you define it in light of sort of 2 observations that I have. One is from a talk that David Sanko gave a number of years ago on building software capital.
Yep.
And at the beginning of the talk, he sort of mentions, you can build a software program and it'll work over time. And if you continue to build up technical debt, it'll still continue to work and still puts all these blocks on top of each other until one day, like the technical debt just kills the whole project and you can't make things work anymore and it sort of dies. And so using your sort of definition, technically that could be good code because it's recursive and it's working, but then one day it doesn't. And the second observation is that I'm sure many of us in the room, I know I personally have worked with newer engineers out of school, and I'd like to think that I've written, some really, really good code, and then I see a month later, I go back to it, and it's been mucked about with, and I thought it was good code, but it definitely didn't get good code from working with sort of newer engineers with less experience. So, anyways, just wondering if you have thoughts, sort of, is that really how you define it, or
Yeah.
what would
So
you say with respect to those sort of
yeah. So to me, that the rest of the talk I don't care about. The only part of the talk I care about is good code begets good code. Because this is like, to me, it's a recent revelation of mine. It's kind of obvious, but it's kind of a revelation in that, like in David's example, right? You had working code, right? And then one day it stops working. Doesn't go like that, right? What happens is you have working code and slowly bugs creep in. And you kind of say, well, like code isn't works or doesn't work. It works and then slowly works not quite as well, right? And the efficiency goes down, bugs appear, and over time the code slides to completely not working, right? So that code was bad long before it stopped working, right? Bad code is code, like you don't know if code is good or bad until you look back 5 years later. And the good part about this is what you can do is someone says like, oh, that code you wrote was bad. And you go, well, it's the fault of the person before me. Like, if they had written good code, I would automatically write good code, right? So it's their fault, it's not my fault, right? But now I remember that I skipped over a whole thing about, it's called pit of success, right? Which is a term by Rico Mariani or something. Just look it up. If you look it up, you'll find like people talking about his thing, because he never wrote it. He gave it as a presentation at Microsoft years ago, and then people wrote about it. But that's where it comes from. And he finally put it up online so you can find him connected to it. But pit of success is code that the obvious thing to do, your first idea of how to fix something turns out to be the right idea. Like you just fall into the pit of success, which is what, like when I rewrote this image class, you can't leak it anymore, right? As I changed 100 files, I fixed memory leaks. So our code was working, but not working because it had bugs in it. Our code's kind of funny because we align projectors, we do all this work, and then you shut it off. Because we're not running while the movie's playing. You pre-align it, you tell the projector we upload information to the projector, and then we're done. I can have tons of memory leak because my code doesn't run for more than an hour, right? Which just means we prioritize our development a certain way, right? But I went through the code, and the image class fixed a bunch of memory leaks. And if you try to introduce those memory leaks, you'll have a hard time. Like, you can allocate an image, but I don't give you. We used to have a function that would do it for you. Now we don't. We had a function called blank. If we return a blank image, and then you would do stuff with it. Now we have a function called the constructor. It constructs an image. You don't have a pointer, right? And that's really the key to the pit of success is the same as good code begets good code. Just a month or two ago, a coworker said to me, they said, "Oh, I just made changes to this code. He added a new feature or something to this code that I had just been, I was the last guy to touch it, so it's my code, right? I had touched it last, and he went and made some changes to it, and he's like, that was really easy." And I love the fact that he noticed that somehow this was abnormally easy to add the feature to this code. Because typically you're like, oh, how am I going to do this? And he's just like, he went in there. The first thought that came to him was like, obviously I should just do this. And it's like, yes, that's what you should do. So, it's hard to give, that's a whole talk on how do you make pit of success code. But that's what you're targeting. And that's also where between all the types of good code, all the words that form good code, your library might be more complicated internally, but it makes a better interface externally. And so it's like, well, my code's no longer simple, but the calling of it is simple, right? That happens a lot. And then you have to decide the trade-offs. Am I more worried about all the people that use it, or am I worried about a couple of guys who maintain it? But I just felt like when people talk about all these properties of good code, I keep asking why. Why is maintainable a good thing? Why are these things good? And the whole goal is to have code that lasts a long time, knowing that it's going to change and knowing that the code around it's going to change. So anytime you go to make a change in code, I have an example at work where we save PNG files, and then we decided we have to attach some XML to the PNG file so we can load it back up and pull this data out. So we have a function that takes an image, no longer as a pointer, now takes an image, constref, and a file name, saves it, right? Simple. But now it has to also take XML. And it's like, well, should we attach the XML to the image? Should we create a PNG writer thing that you attach the XML to that and then call write? There's 10 ways of doing this, right? And almost all of them will lead to misuse. And I'm just like, no. Just change this function, pass the XML in. Don't even try to think of something better. Because his thing was we could call PNG write, and then we could call another write that added the XML on the end. I'm like, yeah, but you don't know where it goes in the PNG and all stuff. It's like, just keep this. This case was like, don't build an interface, just keep this simple. But my criteria for which way should we do this, and he did. The guy was like, I can think of 5 ways of doing this. I'm like, which one of these will get misused and which one won't, right? Because if you start adding XML to an image class, people are going to attach the world to your image class, and then they're going to use it as a global variable. It's like, oh, I wanted to pass you this and X and Y. I'll just tack it on the bottom here, because that developers are great at solving problems with whatever is closest. So, oh, I've got model, I can solve this. Oh, I got an image with I can attach this thing. It's like, oh, I could just use a global variable. I could make a singleton. So you just want the thing, the things that they have at hand is oh, those are the things I needed. And here's the patterns we always use, so I know if I have to do something, I follow the same pattern.
It sounds like you're sort of saying what Scott Myers and I think also Ben Newman's talk subtitle, easy to use, hard to misuse.
Yes.
If like I said, the new engineers it's easy enough for them to build muck about it, it's not good for them.
Yeah.
All right, thank you so much.
I think, like, we definitely have, there's certain lines you draw, right? We definitely have a line between the UI and not the UI. And it's been blurred. But we know we want to have that line because we want to, like, we know what our future plans are. We want to separate these things for various reasons. And there is, it's such a silly fundamental problem in programming is not only will developers use whatever is at hand, when they're adding new code, they will add it wherever they are, right? They're like, oh, if I add an if statement here, that'll fix my problem, so I'll add it right here. And then it's like, oh, I need to write a new function. I'll just put it in this file because this is where I'm going to call it from. And they might realize, oh, I should write a class. I'll put this class beside the other class because that's where I am. I'll put it in the same project I'm in. You always do whatever's the simplest or easiest and laziest thing to do. And that's a hard problem. And when I see it, and some of this comes down to code review and things like that, and just talking, having your whole team talk to each other, it's like, well, who else is going to use this, right? And if you start out with a decent structure of like, the names are always bad. We have framework, and inside framework is common, and so things go into common, but it's like, how common is common? Are projectors common, or are they only common to this project? Or is it, well, it's common to everything Christie does because we make projectors, like, but if you can build a few layers of your code, you kind of go, oh, everyone's going to use image. We have 3 image classes right now, and a 4th on the way. So I'm actually fixing this one so it matches the long-term one, so we can get down to 2 and then 1, right? It's just a hard problem. You know what? It's John Lakos, right? He's the king of like how to structure giant code bases. Someone's telling me the time is up, but I will come up and talk to me after. That is the answer.